Right. Yeah. Thanks a lot, everybody's and joining today. And today I'd like to talk about more like kind of conceptual ideas about how we can connect the kind of individual curiosity as a scientist to explore research, and then how actually the science itself grow itself. And before I'd like to talk about the milestone thing, let me also introduce this videos about like Professor Tasuku Honjo. He got a Nobel Prize in 2018, and he talks about what is important as a scientist. And he mentioned that curiosity is the one that we have to have. I don't know. Yeah. Right.
The audio is coming. Audio isn't coming.
It's not working. It's okay. I mean, just it's already there's the app. So he mentioned you have to have curiosity as a scientist, and if you don't have it, then you better go somewhere else. That is kind of his message, and this is a kind of cliche I think I often see as a scientist, but at the same time, I'm also curious about why people say that kind of stuff and how those are somehow associated with the scientific laws. The question here I'd like to talk today is about the how, sorry, I don't like this. Right. How does this a personal driver, curiosity, actually lead to global scientific progress? That is the kind of things I would like to talk about today. And that is, I think, highly associated with Dr. Hayashi's talk and everybody else. And let's go back to like corrective predictive coding as model science in the first phrase, and looking about this model as kind of individual selection of scientists. And I like to put theory of individual curiosity. There's in a cognitive neuroscience, in cognitive science, there's a theory about curiosity, and somehow it's like about individual curiosity. So nothing related to more collective curiosity. I want to somehow bridging the gap between the personal curiosity and how a scientist works. And I'd like to also mention this collective curiosity concept. And yeah, by doing so, we have more better overview of this hypothesis. I think the good point about this corrective predict coding is that we can deal with this corrective curiosity in better definition somehow. And I would like to talk about the implication a little bit. And yeah, these are the things that we already talked about again and again. The things is that agent as a scientist try to observe and do the experiment, observe new information. They publish the new informations as a kind of global scientific representation. And by doing so, this global representation itself somehow constrained or like abuse of doing science. That is the kind of things we are working on, this framework. And let's see, like this looking back, this CPC MS model as like individual selections. The framework itself talk about like more global view. However, each individual has like decentralized agent and somehow supposed to select what kind of theme you want to choose. In that case, it's like what kind of target you want to find out or focus on is this kind of selection programs. And you can have like a infinite resources to tackle on the scientific problems. So you choose something like important to you. That is the things like, as an individual scientist, it's very like, yeah, what kind of thing you want. And another thing is they like be like what kind of hypothesis like you want to also test. And in the framework, I think Dr. Hayashi also already talked about it a bit, but the important things is that when you do experiment and it's kind of action, but that actions also the following with the global representation, what kind of context exists in a science. And based on that, you try to somehow change your internal representation. This is the kind of hypothesis testing. And then after you change your internal representation, you try to also change the external representation. That is how it works. And the question would be like what actually drives this kind of actions experiment for similar selections and hypothesis testing as a individual scientist. And that is like one thing to be the curiosity. So curiosity is kind of internal driver, like as Professor Honjo mentioned a little bit, for the explanatory behaviors. In these cases, we talk about like the hypothesis testing, the sim selection. What kind of things important to you? And in this theory, actually, there are two types of curiosity that is mentioned. One is like perceptual curiosity, that is totally like perceptual novel stimuli to you. And this is not so much, I think, related to scientific activities, but at the same time, another point would be the epistemic curiosity. That is something, the drive to know. Well, there's nothing perceptual, but something after you get the information, that reduce the uncertainties of the world and also leads to the acquisition of knowledge. Daniel Baring actually talked about this curiosities. And in 2090, the economist actually, he mentioned about this curiosity somehow maybe like associated with entropy. And also information gain, how much you can gain the information. That is quite important when it comes to the exploratory behaviors. And his theory is that curiosity itself is somehow an embedded U-shaped structures. So you have a middle, so not so much knowledge about the context, then you don't have a much don't want to do something to explore. And if you have a higher knowledge, then you also don't want to do somehow exploratory behaviors. But if you have somehow the middle knowledge, then you have kind of you want to somehow more explore, and like information gains much higher in that case. That is like Lowenstein mentioned about curiosity actually works as an individual. And seemingly this is the true in some senses. A lot of theories actually inspired by this theory, and I think one active inference also inspired this series, and seemingly it's very active right now. And this is not only the one things recently studied, and somehow recently people working on what kind of actually like structure actually drive this kind of curiosity. That is what people's right now talking about. And recently, the one paper published, this is still, I think, in archive, but they ask the subject to look through, Wikipedia pages every 5 hours, like 20 plus day, and they look at how each individual explore this concept, sorry, this Wikipedia pages. And Wikipedia pages are also somehow analyzed by like cosine similarity, like how this concept networks actually look like. Then what they found is that seemingly the individual curiosity, one type of curiosity, so-called deprivation sensitivity. So this means that you want to somehow explore more because you're somehow anxious. You can't stop, exploring things. And they also see what kind of structure actually associated with that. And what they found is that somehow this like deprivation sensitivity is associated with concept clustering. How much each concept that connected to each other. That is like very important. How cluster how higher the concept clustering that is very important seemingly. So the important thing is that somehow each individual curiosity is also affected by this structure of the concept itself. Right. So individual curiosity is associated with connections between a known knowledge. And seemingly, so there are other studies. It's a growing, I think, field. Is that a lot of people's working on like how scientific knowledge itself actually grows. I think this is very important because this is kind of somehow the global representations in the CPAC MS framework, and as if the knowledge itself grows, although like a lot of people contribute to it, and how this concept actually grows, it matters with the each concept, how those are connected to each other, how much does that has an impact is seemingly influenced by the structure of the concept. So that what this paper Ju found out is that if the concept actually has higher modality and clustering, then that has a higher like scientific impact. And other studies also looking at the like how this concept of science actually grows, depending on what kind of concept actually proposed, how those are connected with like a core concept or like a periphery concept. That also change, so influence the impact of science. That is the somehow reflections of global representation, and seemingly that is driven by the summation of individual curiosity. And the important thing is that I think this conceptual network goals is somehow collective exploration driven by like collective curiosity. And the things I want to mention is that since we can talk about global representations, we can start talking about how what's the relationship between like this global representation and the conceptual network goals somehow, and how this like conceptual global representation actually itself grows. It's kind of things it is associated with its structure itself, and that structure itself can actually generate the collective curiosity of each scientist. And I think that there are two types of the curiosity can drive. One thing to be like a curiosity toward trends. Somehow you in a field and you want to have a higher impact in the field, and your proposal might be somehow in the centers, and you have a higher citation, but maybe you fail to locate your research. Somehow you just research is periphery. In that case, you don't get much fames. Rather, some people wants to like against the trend. In that case, maybe you adjust the periphery from the field A field, but in some cases, like maybe you have a better you can connect the different field. In that cases, maybe you can have a much higher fames. So each individual try to somehow coordinate yourself with and your concept and where your proposal located. I think this CPC is something like try to locate connecting a different field. That is the things I think a lot of people gain got attention on this framework somehow. And this is somehow already Professor Taniguchi mentions, but global representation is somehow kind of analogous to concept networks, and that somehow influence individual curiosity, and they actually do the experiment, and somehow that changed concept network. So I go back to the original questions, and my answer is like individual curiosity somehow constrained, influenced by, and driven by concept network and global representations and dynamic structure changes, maybe phase transitions, like according to Dr. Hayashi's concept networks recursively change by this individual curiosity. So by doing so, individual curiosity is quite important to change concept network. So I think, yeah, pretty much this is it. But so I want to mention that this collective curiosity is associated with information gaps in the concept networks. And this scientific concept network is a type of global representation in the CPC framework. And this individual curiosity is affected by global representations, which also drives collective curiosity. Like a lot of scientists got curiosity to do some kind of stuff, experiment. And from concept networks, I think we, including AI scientists, may have predict and generate emerging field of science. That is a one I want to discuss and mention these presentations. But yeah, those last but not least, so far we mentioned like multiple one type of global representation, but based on the which community you are, global representation might be changed. So in that cases, the CPC framework is quite important, and also concept networks is important. How this networks, like how you see the world itself, is quite different. In that cases, how interpretations of networks are different. So in that cases, the impact of the scientific proposal may change in a different community. So maybe you have a better impact in the different community, but not so much in other community. So CPC, I think, might be can be a model for this. Multi types of science can be academic science. All right. Thank you so much for your attention. I think a little bit talked a lot, but